Welcome to section 10.1, lines and angles. Pause this video often, complete the problems with me and on your own. There are a lot of topics, a lot of skills and understandings here, and most importantly, there is a ton of vocabulary. So pause this video often, get the stuff down, and try your best and review this material. So geometry gives us the tools to mathematicize and model many different aspects of the world around us. So traveling from one location to another, we can think about that as 2 points, or a different route from one location to the other as a line segment. We could use geometry to model it, or a math drawing, and show how things are related. There are so many different ways that we can use geometry, and so we are going to study some fundamental concepts in this section. So first, let's start with 3 vocabulary words. A point is a tiny dot, and it has no size or shape. A line is infinitely long. You can think of it as stretched string, no beginning and no end. And a plane, a great way to think about a plane is a flat piece of paper that has no beginning or end, and no thickness. Now, a line and segment and array are a little bit more specific. So a line segment lies between 2 points on a line. Oops, let's get a different color. So these are our 2 points, and these are called endpoints. And so a line segment has a beginning and an end. A ray has 1 point, and then the other is a line. So a ray has a starting point, but it has no end. So when we define angles, we will study key facts about the configuration of lines in a plane, including the fact that the sum of angles in a triangle is 180, and describing angles in 2 ways, using rotation about a fixed point, and then angles between 2 rays. So let's talk about an angle as a rotation around a fixed point. So rotation is something we have definitely seen before. You can spin around. But our first definition of angle is the amount of rotation about a fixed point. So at an angle at a point P is said to be congruent to an angle at a point Q if both represent the same amount of rotation, even though the rotation takes place around different points. So what we're measuring here is this is congruent, even it doesn't matter the direction, but the angle of rotation. Okay, and we're going to talk about congruent here in one moment. So congruent and equal are often interchanged. Things that are congruent are shapes and angles. Things that are equal are numbers. So an angle measure would be equal because that's a number, but an angle itself is congruent. And don't worry too much about that, but that is important geometric vocabulary. So now an angle can also be considered between 2 rays. So this here is our angle P around the vertex P, and a vertex is where 2 rays meet, or 2 line segments meet. So you can kind of think of rotating one ray around the vertex until it reaches the other ray, and that can be a way to kind of keep those together. So how do you name angles? Well, if this is a vertex B, and we're talking about this angle here, we always put the vertex in the middle. So we could say it would be A, B, C, or C, B, A, but the vertex is always in the middle. Now, if we were to measure this angle here, we still have the same vertex. So we could say A, B, D, or D, B, A. And here, if we don't know the vertex or the ray's letters or names, we would just call this angle A. And that's like a little angle measure. And we measure angles with degrees, and we use the degree symbol. And there are some special angles here. So when we rotate around a full circle, that's 360 degrees. When we rotate around a half of a circle, so we're still at this vertex here, so this distance here is 180. This angle here is 180. This is 360. If we go just a quarter turn, we're looking at a 90-degree angle. And then just a little ways, I can barely even draw that, would be 1 degree angle. All right, let's look at this example. Tiffany says that the angle at angle A is bigger than angle B. Why might she think this? How might you discuss angles with Tiffany? So if Tiffany thinks that this angle is bigger, if we look, we can see that the angle measures are equal, or the angles are congruent. But what's different about these? Well, angle A is using longer line segments or longer rays than B. And so maybe that is why Tiffany thinks that the angle is different or bigger in A. And so we would just describe that line segments do not determine the angle, right? That would be how we would address this misconception with Tiffany. And here is it written out for you. Go ahead and give this one a try about angles. Press play when you're ready to see the solution. And there we go. So when we think about angles, we talked about that 1 degree angle. We can think of all angles as being made up of 1 degree angles. So here we've got 23 1 degree angles, so this angle measure is 23 degrees. There are different names for different angles. So angles that have a pointier look than larger angles, that are less than 90 degrees, we call these acute. So these are less than 90 degrees. And obtuse angles are larger than 90 degrees. And right angles are exactly 90 degrees. And straight lines, or a straight angle, is 180 degrees. So let's look at this example here. Which angles are right, obtuse, and acute? So a right angle is exactly 90 degrees, and that is going to be indicated by that little square. So angle C is right. And obtuse is anything greater than 90. So because 138 is greater, that's going to be angle B. And acute is going to be A because it is less than 90 degrees. Now, you can use a protractor to measure angles. Now, when you use a protractor, you're going to have a little hole, and it should be placed directly over the vertex. And we talked about the vertex before. And so then you've got a horizontal line, and then that should be lined up with that bottom, let me use a different color, bottom line here. And then the other ray should line up with your angle measure. Now, again, you might be like, hey, is it 115? Or is it 65? But you can look at this angle and say, hey, that's less than 90 degrees. That's going to be 65. And just being really careful, you can move your paper or the protractor as needed, but you do want to have that little T right in the middle. Now, in the classroom, it's fun to do angle explorers and play around with angles rather than jumping right into a protractor. All right, so I'm going to try to do this to the best of my ability here on this computer screen. So I'm going to use the protractor to measure each angle. So here, let's put this in the front. All right, so here, do you see how that, I'm trying to measure this angle here. So I'm going to actually rotate my, my image here. I probably should have started with a different one, but I want my horizontal line to be matched up with that bottom line. It's still just like a hair off, and I'm not sure if I can get it perfectly. So the idea is I want to get the vertex, the corner right in the corner there, and I want this bottom line to match up here, so then I can see, okay, this angle is 60 degrees. And it won't stick on it, but that angle there, so if I was to kind of draw this image here, that angle there is 60 degrees. Now I'm going to rotate this and show you how I'm going to measure the next angle. Oops, if it'll let me. So now I'm going to get this angle, and I want that one to be flat, and it's not quite there. So now, see how my vertex is over here? I need to move my protractor to where that vertex is. There we go. And it's lined up, and now I can see that this line is hitting at about 120. So what was that over there? 120 degrees. Now we could also move the protractor as well if we weren't able to move our line. And that's not going to work because we need the interior of that angle. And now I'm forgetting which angle. So we'll just do this last one together because I can't mark them. And you can see here, okay, I need to get this bottom line to match up with that one, but I need my vertex in there. And maybe I already did that one because you know what? That looks like 120. So that's how you use a protractor, and I'm sorry that I didn't keep track of which angle I was able to use. I wish I would have labeled them before we started. But I've tricked these so that they're already set up for you. So if you don't have a protractor at home, that's okay, but you can use your screen or the slides to print these out and measure these angles and press play when you're ready to see the solution. And we'll pause there and continue in the next video.